Hello, this is a video over Chapter 3, Lesson 1 for Pre Algebra. Make sure you have your study guide out in front of you to follow along, and let's get started. So, this lesson here is over fractions and decimals. And the cool thing is, I hear you guys did this in 6th grade. So, this is kind of just a review for you. We're going to take a look at turning a fraction into a decimal. So, can anybody in the class think of how you would do this? If you think you know, you can just give a thumbs up, okay? So think for a second, how do you turn a fraction into a decimal? So if you said divide the numerator by the denominator, then you are spot on. You've got that right. So that's what we're going to practice today is we're going to turn our fraction into a decimal by dividing the numerator by the denominator. So if we look at our examples on your study guide, example 1 and example 2, that's exactly what they do. They do 7 divided by 8. And you're just going to work that out. Of course, needing to put some placeholders and decimals in place if your number that's divided is less than 1. And if your decimal is repeating, then you can turn your answer into a number as a decimal and then putting a line above the repeating values, right? So if this is 4 repeating, 0.4 repeating, then it's 0.4 and then with a line above. If you see a decimal that's like 0.232323 repeating and it keeps going, then where do you think you'd put the line over? You'd put it over what's repeating, right? Which is 2 and 3. So you put your line over that. If you see a decimal that's like 0.1 and then 2, 2, 2, 2, 2, and it keeps going, where would you put your line over? You would put it over the 2's. You wouldn't put it over the 1 because the line over the number shows that those are the numbers that are repeating. So these are just some examples of how you would put the bar or the line over your repeating digits. So looking down below, there's a few problems here. We're going to do some of them. Notice we've even got some negative numbers. I'm going to switch to a different whiteboard here. And I'm going to do some of these with you. So we're going to do maybe 1, 2, and 3 together. And then I'm going to let you loose and see if you can complete the rest of those, okay? So number 1 is 7 divided by 20. So remember, we're dividing the numerator by the denominator. And so 7 is going to go inside my long division symbol, and 20 is going to go out here. Now, I'm doing 7 divided by 20, which means I don't have enough to divide. And so I'm going to put some placeholders. I'm going to turn this 7 into a 7.00 maybe for now. And we're going to divide and look at this as a 70 now. So 20 divided by 70. Well, how many 20s can go into 70? The maximum amount of 20s go into 70? I think 3, right? So 20 times 3 equals 60. I'm going to subtract and leave my remaining amount, bringing it down, subtract and bring it down, and then I'm going to pull my 0 over to make another placeholder so that I'm looking at 20 divided by 100 now. So 20 times 5 is 100. And so that is my answer. Now, is my answer 35? No, it's not. Look at where my decimal is here. I'm going to bring that decimal back up and then put a 0 as my placeholder. And you could have done this right at the beginning. So if you did, then you're ahead of the game. And my answer is 0.35. Okay, so number 1, the answer is 0.35. I would like to see your work. I would like to see your long division work. So on your homework, if you're doing a problem, then show the show the problem here, and then on the side or underneath, show the long division neatly, and then show your answer, and you can highlight it in a color, or you can circle your answer. I love it when you circle your answers. So whatever you circle here, and you don't have to circle, your work, your long division work, but wherever you show that your answer is circled, and I've labeled this number 1, that would be ideal. Okay, let's take a look at number 2. So number 2, we've got 2 over 11. So we're going to divide 2 by 11. So the numerator divided by the denominator. Now, 2 is not big enough, so I'm going to make it a decimal, put some placeholders. And I'm also, my last problem, I didn't put my placeholder right at the beginning. Maybe get into the habit of doing that right at the beginning. So put your 0 point, and then look at this as your 20. So 11 goes into 20 once. Subtract, and I am left with 90. 11 goes into 98 times as an 88 with a 2 remaining. And then if I bring a 0 down again, put another 0 and bring it down, I've got 20, and so it goes in once. I've got that as 11, and I'm remaining with 90. So are you noticing how I'm going to just keep getting 20 and then 90 and then 20 and 90 as my amounts that I'm being divided by? So it looks like my decimal is going to be 0.181818, and it's going to keep going. So I don't think I'm going to get away from that pattern. So my answer is 0.18 with a bar over 1 and 8, and that's my answer. Okay, number 3. 5 over 9, turning this into a decimal. 5 here, 9 on the outside. I'm going to put a placeholder, 0 point. I'm going to look at this as 50. So 9 times 5 is 45. And I'm left with a 5 as a remainder, bringing my 0 down. Again, I'm times 5, 9 times 5 is 45, and it looks like I'm just going to keep getting 5s as my remainder over and over and over again. So I'm going to write this as 0.5 with a line on top to show that it's repeating. Okay, I think you guys get the idea. So if this fraction was a negative, then remember we've talked about negative problems. If it's a division problem, if I have 1 negative, then my answer is negative. So this is the same case. If I have 1 negative symbol over my over my fraction, well, my answer is still going to be negative, right? And so if I have 2 negatives, right, a -5 over a -9, then those negatives would cancel out. But you're probably never really going to see this as a fraction. We're just going to put the negative just right out here. So don't forget to tag that negative on as you write your answer, that your answer is a negative, if it was a negative. Number 3 is not a negative, so we don't need to have that down. But if you look at number 13, you know that 13 is a negative, so the answer is going to be negative. All right, so you can pause the video and work these out. I'm going to write the answers on the study guide so you can check your answers. And then once you have checked them, then you can play the next part and watch the video for the back side of the study guide. Okay, let's take a look at your answers. So if you want to pause this and just check, you are welcome to. I'm not going to sit here and go over all the answers with you because you can pause that and take a look. Let's look at the bottom or the back of the study guide. So here what we're doing is we're just making sense of your fractions and decimals by comparing them using your inequality symbols. So remember, this is your less than symbol, this is your greater than symbol, and then your equals to. So we are going to replace this little circle with a greater than or less than or equal sign to just turn this into a comparison between the two values. And if you're ever not quite sure which one's greater or less than, think of it in terms of a number line. So we've got a picture here of a number line where they've turned 3/8 into a decimal so that the comparison, you're looking at them both as decimals. So I believe that will be our challenge here in this lesson, is just turning your fraction into a decimal so you can make sense of them, right? So in example 2, when we turned negative 0.37 into and negative 0.36 repeating into a decimal, we can look at them as just decimals. And remember, if you've got a negative, think through your number line. The more left it is, the smaller the value is. And so if, even though it looks like it's bigger, 0.37, you might think, oh, that's a bigger number. But because it's negative, it's smaller, it's a lesser value, it's more negative, and so it's smaller. And so even just looking at this, and if you look at the tens place, they're both 3, so then you have to look at the hundreds place and compare them now, 7 and 6. 7 is greater, but because it's a negative, we've got this as a lesser value. All right, so looks like we need to turn these into decimals to be able to compare them. So I'm going to switch over to a different screen here and take a look at 1, 2, and 3 with you, okay? So number 1, we've got 5/8 and 6/9. Now, because they don't have the same denominator, it really is hard to make sense of them. So we're going to turn these both into decimals. So working it out by doing 5 divided by 8. Okay, bringing my 0 down. And then bringing another 0 down here, and this becomes 5. And so 5/8 is 0.625. Okay, so I'm going to just write this underneath, maybe in a different color, so that we can make sense of that amount, 0.625. And then we're going to work out 6/9. And 6/9, if you simplify it, that's 2/3, right? Does anybody know what the decimal for 2/3 would be? Okay. So looks like we've got a remainder of 6 that just is going to continue to repeat. And it's going to keep going and keep going and keep going. So this looks like it's a 0.6 repeating. And put that underneath here, 0.6 repeating. So if I compare the two, if I've got 0.625 and 0.66666, and it's just repeating, which one is greater? So I'm going to compare their values, right? Here in the 10th place, it is they're both 6, and then in the hundreds place, we've got 6 right here being greater than 2. So the winner is 0.6 repeating, right? And so I would write this as greater like that. Okay. Number 2, 4/5 and 0.8. Well, because one of them's already in decimal form, I really just have to do this one here. Okay, I'm going to put a placeholder, and then 40 divided by 5 is 8, and that's 0.8. So that means they are the same, they're equal. Okay, so number 2, they're equal. All right, number 3, 7/8 and 4/5. So again, we're going to work these both out. This would be 8 times 8 is 64. Remainder of 6. Bringing this down. 8 times 7 is 56. Remainder of 4. Bringing a 0 down. That would be 0.875, 0.875 for that. Let me complete that there. Okay, then 4 divided by 5. We did this one, didn't we? So this would be 0.8, right? 0.8. So this is 0.8. Which one is greater? Well, think of my values here after the 8 would be 0, 0, 0, repeating forever. And so it'd be 0.8, 0, 0, 0. And so here we have 0.875 and then 0.800. So when I look at my hundredths place, I've got a 0 here and I've got a 7 here. 7's greater, therefore 7/8 is greater. So I'm going to show a symbol like that. That's greater. All right, you guys do the rest of these. Careful with those negatives. Maybe we'll do number 8 together because number 8 has negatives. So let's just use that as like a little review for us. We've got -3/10 and -2/5. So when I work this out, I think I've got a -0.3 as a decimal and then a -0.4 as a decimal. Now, you might have done so many of these problems that you're like, oh, whichever one's bigger is greater. When we look at this, our instinct is to say, well, 0.4 is greater, so it's bigger. But because it's negative, be careful here that 0.3 is actually greater, because if I were on a number line and this is 0 and this is 1, this is 0.5, 0.3 would be right here, and 0.4 would go right here. And remember, they're both negatives. This is all negative, negative. And 0.3 is farther to the right, and so that's greater. So when in doubt, put it on a number line, draw it out. All right, pick a few of those, do them, and compare with your partner, with your classmate, and then you can check your answers. I'm going to put them up here so you can pause the video while you're working on it and check your answers. Okay, so let's check our answers here. If you wrote down the decimals on the side, then bonus and props to you, because it's always helpful when we can see our work and what we're really comparing. And so this actually has more significance and value to us, seeing the decimals here. This has more value and significance to us as we compare the values. So if on your homework you write this out, then I would be so happy, okay? All right, I think that's all we have for today. If you are completely done with this, then you can make up some problems for your classmates to work on and see if you guys can get those right.